Good afternoon, ladies and gentlemen. My name is Oliver Ramos, and I would like to start by saying on behalf of the team here at PB Tech, thank you all for joining us for today's webinar, where we'll be hearing from Roberto Murgioni, the Technical Service Manager at JinkoSolar. Before we hear from Roberto, I just want to go through today's agenda. The webinar will be lasting about an hour long. The presentations will be about 30 to 35 minutes, and we'll have a few breaks. We'll be running a series of polls, allowing us the chance to engage, adding value and live feedback. Roberto Murgioni has kindly joined us today to discuss LCOE, PV and large-scale plant using Jinko module technologies. Roberto holds a Bachelor of Science degree in Electrical Engineering and a Master's of Renewable Energies Engineering. Roberto is responsible for pre-sales and after-sales activity around Europe for JinkoSolar. He has an extensive experience in working with various EPCs, especially in managing large PV plant projects in Europe and Latin America. Ladies and gentlemen, Roberto Murgioni.
Good afternoon, everyone. Again, this is Roberto Murgioni from JinkoSolar. Thank you, Oliver, for the great introduction, and thank you, PB Tech, for the opportunity. So, I would like to start immediately with our presentation today, which will focus in LCOE results. So, let's start immediately in showing what will be the structure. I will then immediately introduce JinkoSolar as a company. Then I will speak about quality concept, and we will move directly to the LCOE concept, speaking about the new technologies from Mono-PERC, half cell, next generation poly, and then we will focus in LCOE results, tool, and expectations. And then we will finally summarize all the results. Okay, so far JinkoSolar has 15,000 employees around the world. We are present in 80 countries, and we actually delivered 29 gigawatts. Last year, the capacity was almost 9.8 gigawatts. The core of our presence in all global markets is actually our laboratories and our R&D department. We have 155 people working and researching new technologies that I'm gonna show now. Our product portfolio actually is the one you have in front of you. As you can see, solar market is changing dramatically the offer. It's not more about poly and mono, but now we have Mono-PERC, new poly technology, smart module, Eagle Dual, half cell technology, bifacial will come for the mass production next year, but already in present for this year, and also the new technology with 12 bus bars. Speaking about large-scale plants today, we will focus in half cell technology, poly technology, and Mono-PERC technology. Quality concept. In Jinko, we have a vertically integrated production, so we start with the ingots and we control every process, every line till the end, till the PV modules. So we can guarantee along the complete value chain the quality, and actually it's an optimized cost structure with more than 10 years of experience.
Roberto, hi. I think this is a good time for us to run our first poll, which should be coming up on screen soon. Now, this allows the audience to engage as much as possible. So to start off with the first question, which model type do you believe currently offers the lowest LCOE? So we've seen that most people have said poly-standard. So thank you very much again. So I'll now pass back over to Roberto. Thank you, Roberto.
Okay, thank you, Oliver. It's a curious result, and it's becoming more interesting to show you my results. Okay, fine. Well, I will show you that there is no, let's say, specific formula to say poly is better, mono is better, half cell is better. But there is a specific case in every environment, in every zone that we can calculate. But we will go through. We will go through later, and I will show you that actually it's not completely true that poly-standard is the better solution. But most of the case is the opposite. But let's go ahead. All our portfolio has a PID resistance value. And I mean, I would like to remind that it's not PID free, but PID resistance when we speak about modules with frame. Moving forward, there is also inside the zero MICROCRACKS program, because we realized that MICROCRACKS in the past has been a problem that nobody actually were completely aware, and we are trying to improve our pre-shipment and post-shipment deliveries in order to reach the zero MICROCRACKS at all. Okay, let's move to the core of this presentation, and let's see what kind of results we will get. Speaking about Mono-PERC technology, it's nice to introduce the module which actually can get 5% power more than a mono standard, just because we are going to passivate the layer on the back between the backsheet and the cell. And I mean, we are going to increase the module efficiency boost about 1%. This you can see here a clear image of what is going to happen in the passivated emitter rear contact. The main advantage for this technology is actually that, first of all, it's a mature technology and we have a long track record. There is a high potential for further cell efficiency increase, and it's the most cost-effective CSE high efficiency leading the technology right now. This is for Mono-PERC. Moving to half cell. Half cell is a new concept where we are going to actually cut the cells on the half. And here you can see the front of the panel, then the back, where the injection box is located in the middle, and also the electrical circuit. From the electrical circuit, you can immediately understand that we don't have any more 9 ampere in the circuit, but we have 4.5 in the up zone and 4.5 in the down zone. Just to be more precise, on the left, you can see the 2 different panels working. By cutting the current to the half, we are going to decrease dramatically the losses. The formula is clear. Power losses is related to the square of the current. And by also cutting the half of the cell, we are going also to increase the temperature coefficient of the panel. One aspect which is very important is also the shading mitigation. In this case, in the standard solar module, with this kind of shading, we are going to lose all the 3 substrings, mostly all the panel with 0 power output. This is not going to happen in the half cell, where half of the module is still working. So we're speaking about 50% power output more. And then let's go to apply this technology to our LCOE study. Okay, how can Jinko technology reduce the LCOE value? First of all, we are going to apply our study only in one area, of course, and it will be the DC design architecture, because this is the area where we can only work and we can only modify and improve our numbers and optimize the DC architecture design. Which way? Of course, impacting the BOS. Okay, let's define BOS. The BOS refers to all components of a PV system other than the modules. So in addition to inverters and racking, this includes cables, wires, switches, enclosures, fuses, ground fault. I mean, the cost of balance of system will include hardware, software, permitting interconnection, inspections fee, and any other fee that may apply. I mean, for large commercial solar system, the cost of BOS may include also the cost of the land and the building. So, moving forward, let's see where especially we are going to affect the BOS. In principle, the technology will affect the O&M cost for sure. All the solar cables and DC main cables, the quantity of DCCBs, the logistic costs, the conduits and trench costs, and definitely the racks costs, the mounting installation costs.
Brilliant, Roberto. Thank you very much. I think it's time to maybe run our second poll. I want before to do this is to say please do keep sending in your questions. We've received a number of questions which will be heading at the end part after the presentation. So our next poll, which should be coming up on screen now, is how much land can be potentially saved using Mono-PERC modules instead of standard poly, which many of you have agreed that 10% and 15% have been shown in results. So over to you, Roberto.
Okay, thank you again. Again, nice results, quite conservative. We'll show why we can reach almost 20%. Which is a great result in terms of land saving and O&M saving costs. Okay, then let's move on. Before to show you the results, I would like to introduce you how we have got this kind of results. We built a tool, an internal tool, where we can have project inputs with a PV area, location, peak power estimated, inverter type, and operating voltage. When we have a land, when we have a location, we are going to build our DC design, and we can compare our poly technology with different power bin, with outcell poly, mono, outcell mono, and PERC. So we can compare the different Jinko technologies. And depending on the number of the strings of the DC architecture, we are going to calculate all the BOS in terms of logistics, in terms of inverters, DCBs, standard mounting structure, solar cables, everything. This is just a part of our calculation because there is also O&M. There is also many voices that complete the BOS calculation. Then we will calculate through PVSys the simulation in order to get the energy calculation for the 25 years and of course the cash flow. This is just a preliminary result, and the output will be the overall system cost. The overall system cost per watt. We can get the lifetime energy production calculating also the rating of the modules per year, then we have the normalized lifetime energy production, of course, the LCOE, and the ERR value. Then, I would say, let's run a test sample in Sevilla, for instance, in Spain, where we have a site area, AC power of 50 megawatts, and we will start with a simulation with Eagle Poly 320 watt peak using central inverter station with 2,200 kilowatts, and the system voltage will be 1,000 volt. Okay, this is just a test sample. Using standard Poly 320, we have a DC structure like this, with a certain number of modules, strings, combiner box, and racks. And output of, like this one, again, numbers are really conservative because also I am considering the HV connection voltage costs. So everything is included. And this is the US cent kilowatt hour value of LCOE. And the lifetime energy production is calculated for 25 years. But let's move on and try to simulate just, again, the Poly, but 330, and see what is going to happen in our PV system. First of all, the energy output will be, according to the system calculation, remember that the system is always the same. Everything is the same. I'm just changing the panel. And immediately the energy output will be slightly better, plus 0.25%. And let's see how the BOS cost is decreasing by 1.4%. The LCOE also value is decreasing, and the PV area is minus. I'm speaking now about PV active area, minus 3.1%, just increasing about 2 power bin the PV module, but still Poly. Okay, let's now apply the half cell mono 355. With this panel, we can increase the energy output about 1.65%, just because it's half cell, and with this technology, with that environment and the temperature coefficient, we are going to increase dramatically the energy output. Also, we increase the power area ratio, and when I speak about power area ratio, it means how many megawatt you can install in 1 hectare. BOS cost is reducing by almost 5%, sorry. LCOE is reducing about 3.2%, and the PV area is almost 10%. This is half cell mono 355. Same area, same condition, just changing the modules. So if we move now to the standard Mono-PERC 370, we see that the energy still increases a bit, 1.3%. The power area ratio increases. Also, the performance ratio increases. Remember that the reference is the number with Poly 320. All the comparisons are made using that numbers as a reference. The first one you saw in the first slide of 320 Poly module. What about BOS? BOS cost is reducing about 6.4%. This time LCOE is not decreasing like half mono cell, because Mono-PERC costs, the cost is higher. But have a look to the PV area. We are close to 40% less, just using the 370 Mono-PERC. And now, if we move to our half cell Mono-PERC, in this case, we are merging the two technologies where we use half cell and Mono-PERC technology to reach 385 watt peak. Well, in this case, again, we have a 1.4 energy output more. The power out area ratio increases. Also, the performance ratio increases. And having a look to the BOS, I mean, we can reach minus 8.2% in terms of costs. LCOE is reducing about 4.1%, and definitely the PV area is reaching almost 19% less, which is a great result. Okay, this is just to answer you about the second poll. Then, just to show you the material numbers of the comparison. This is the first simulation where we have the DC structure with a number of modules, a string combiner boxes, and an output. Let's compare now with the half cell Mono-PERC 385. You can see that in one side we have 7,812 strings. In the other case, we have 6,493 strings, which is a huge difference. DCC combiner box cell, 326 against 271. Racks, we're going to install 700 racks less, which is a huge area. And the output is still better. We have a better lifetime energy. We have a better LCOE, and we have a better performance ratio. Then, I think it's now, before moving to the summary, time for the third poll. Right, Oliver?
Yeah, no, absolutely. Right bang on it there. So we're going to run our third and final poll. So the questions should be coming up on screen now. How much BOS cost reductions can be achieved with Mono-PERC half cell modules compared to standard poly? Between 4 and 6% and greater than 6%. Very interesting. So over to you, Roberto.
Okay, thank you, Oliver, and thank you to everybody for the answer. I mean, it's clear that we can go, I mean, we can get more than 6%, because by reducing all these components, by reducing almost 20% of land, by reducing O&M cost, logistic, and all the material, even the installation workers' time, it's a cost that we consider it. So it's clear that the BOS cost should be really a focus from the investor point of view. It's not a matter only to focus in the panel himself, but to see and to calculate which technology is the best for that location and which power is the best. So don't look only to the price of the panel and to the technology, to the power, but just try to develop a system where you can calculate the final numbers of your PV plant. That's the target of today. Just summarizing all the numbers. Here we have the lifetime energy in megawatt per hour calculated for 25 years. And it's in this location, for this plant, according to our PV system calculation, the mono half cell is the one performing better. Okay? That's why I suggest don't take this as a reference. It's just a case in Sevilla where this panel with this power, with our DC configuration, is performing better, but can be poly in other cases, can be Mono-PERC in other cases. It's something that we need to calculate. And let's see what is going to happen to the BOS costs. I mean, the graph immediately gives you the image in how the power bin is increasing, the BOS cost is decreasing. And I mean, in USD, for a 50 megawatt DC plant, we are moving to 22,500,000 and more to 21,000, even less. It's a huge number in terms of comparison of the BOS costs. And we can finalize commenting the LCOE. I mean, when we calculate the LCOE is the sum of costs over lifetime divided per sum of electrical energy produced over lifetime. Then, calculated it in US dollars to kilowatt per hour, we can see the difference. And the best performers are the half cell technology, thanks to the energy output and thanks to the fact that poly and mono half cell today reach the same cost as the standard technology. So that make immediately clear why Jinko also in the next year will switch completely to half cell technology. We will not have any more poly or mono standard technology, thanks to this output and thanks to the new technology coming. I mean, other than that, it is pretty much all. And I will say thank you to everybody for listening to this presentation. It was more or less 30 minutes. I tried to go quite fast in order to not get bored everybody. I'm open to questions. I'm open to every doubt will come.
Brilliant. So, ladies and gentlemen, I want to thank you again, Roberto, for the time and effort putting together such a great and informative presentation. We have received a number of questions, so I'd like to thank all of you who have done so. So we'll try and get through as many as possible before our time runs out. So we've got around 20 to 25 minutes. So I thought I might kick off with my own question. Roberto, how are you calculating the BOS cost savings exactly?
Well, it's clear. I worked in engineering and procurement side of EPC in the past, and actually, I've built this tool where, first of all, we design and we create a layout, a standard layout in an area, standard area, so we can calculate exactly how many modules, how many racks, how many DCCBs, how many cables, how many material in terms of everything. And then we will apply the actual cost coming from different offers and taking the average. So, for instance, in a design where we have 320 DCCBs, let's give a rough number. One DCCB's cost 2,000 euro. Then we have one cost, and these apply to all the numbers of the design, because we create a layout, we create a single layer diagram. So as a preliminary design, we can have a clear picture of all the system and a clear picture of all the costs. Plus, we of course apply the O&M costs for the 25 years and all the fee costs for everything. And again, it's quite accurate and it's quite also conservative, because I had the experience to plan many preliminary design, and actually, other than that, after we built the plant, the cost is every time much more. So that's why we apply a very conservative approach in this case.
Brilliant. Thank you very much for that. And a question from one of the attendees. What is the largest size of Jinko power plants in operation and in development up until now?
The biggest one, I guess it's in Saudi Arabia. I don't remember exactly the location, but it's 1 gigawatt and something. 1 gigawatt and 2. It's the biggest plant on Earth so far.
Okay, sure, brilliant. And what will be the values if we consider scenarios with all technologies have same panel power?
Can you please repeat? I mean, what's the question? I didn't get it properly.
So it says, what will be the values if we consider scenarios with all the technologies have the same panel power?
Values of what?
The values considering the scenarios of which technologies have the same panel power.
I mean, in terms of power plant, it depends. I mean, for sure, with grid parity coming in, most of the countries already came, and we are going to have large-scale plants and also distributed medium large-scale plants will be a mix. But for sure, 10 megawatts to 100 megawatts will be the most common one as a size.
Okay, brilliant. And we have another question here: is how much of the LCOE tool is specific for countries?
Okay, this is very specific for Europe. Taking the offers coming from UK, from Spain, from Italy, and from Germany, and making an average. Of course, I don't know specifically the market in LATAM right now or in Asia, where it is a completely another world in terms of EPC market, also in terms of standards. That is why, I mean, it's very specific for Europe. It's very specific, especially for European EPC building abroad, but it's not very specific for North America, for Asia, and for South America, I would say.
Okay, sure. And we have another question here. Is your tool able to make simulations for different size PV plants and for different locations?
Yes, I didn't mention this. I mean, of course, we can make different location and different size. I mean, next step, in fact, will be to compare the difference of BOS cost reduction and then LCOE depending on the size. So I will build a curve just to compare what is going to happen in the 5 megawatts, in the 50 megawatts, in the 100 megawatts, where the BOS impact is really different. This is a case of, this is a very interesting question, because I mean, for 50 megawatts, BOS has an impact, but for 5 has a different impact, and for 100, a different one as well. That is why, I mean, next step will be to do this comparison, because BOS cost can go from 1/3 of the cost of the plant to third. So meaning a huge gap difference. Yes, but the final answer is yes, we can make different comparison, we can run different simulations in different places and just have a preliminary results.
Okay, sure. And I think to kind of add on that as well, is your tool able to make comparisons between central inverters and string inverters, PV plant configurations?
Sorry, Oliver, I would like to ask you to repeat because I didn't hear you very well.
Not an issue. To kind of add on that, is your tool able to make a comparison between central inverter and string inverter PV plant configuration?
Okay, yes, this is a part that also will be in the next step, because so far 50% of the plant in the world right now are with central inverter, but string inverters are becoming more and more important, and the other 50% is built with string inverters. That's why in the the second version of this tool will also integrate the string inverter configuration, because with string inverter, we have a different impact in solar cables and DC cables, because from the panels we will go directly to the small DC box or to the string inverters directly, and then we will have AC. And AC is standard cost for us, because changing the panel, we are not going to change any part in the AC part. But the answer is in next month we will I will update this tool also with this function. The only function that we can have now, I just inserted yesterday that one, is the next tracker option, which is also really common now.
Okay, sure, brilliant. We actually have got an interesting question here. Does the PERC HC also come in bifacial form?
Okay, for bifacial, it's for me, which I'm also dealing with PVCs. I don't trust still the simulation by PVCs, because I don't think they are quite accurate, and there is not really a longer track record. That's why I didn't make any simulation with bifacial. I will do, I think, when we have more precise numbers in the future. So far, yes, we can simulate bifacial, but again, I don't think it's quite accurate PVC's calculation, which is for all the other technologies, but bifacial is quite new, and you have to consider different factors, not only the albedo, but also the high level of the panel, which make a huge difference. Then it's ongoing, it's a process, and yes, bifacial will come also in this tool whenever I will get some results from the field, because we have different plants running and we are testing the output, and also when the simulation will be really accurate from the software. That's the point.
Okay, yeah, understood. And obviously, some people have asked as well, how come Jinko isn't talking about 1500 volts? And care to share?
Yeah, I wanted to show you the simulation with 1000 volts, but I mean, we can do the same. We can run the simulation with 1050, 500 voltage, that's for sure. And it will make also a huge difference in the BOS, because of course we can make longer string, and we are going to change dramatically the DC architecture. In the other hand, all the components cost more. So you have to balance the two topics, and I mean, it can bring a different results, but it's a different simulation. And yes, I mean, we can, if someone is interested in a 1500 voltage system, I can give the results also for this kind of simulation. You know, it's a tool, and we can run many simulations, and we can have different results depending of all the inputs and depending of the environment. That's the point. So it's clear that we can deliver this kind of simulation.
Okay, sure. Actually, we've got quite an interesting question here. What are the streams included in LCOE calculations? Is it only CAPEX?
Is it only CAPEX?
Yeah.
Well, what do you mean?
I'm not sure. Unfortunately, I wasn't the one who asked the question.
Yes,
it seemed like more kind of what are the streams included into the LCOE calculations, and there's a mention to CAPEX, but I mean methodically, I mean what are all the LCOE calculations taken into consideration?
Well, I mean, we try to design with the best DC configuration, trying to reach the voltage, the perfect voltage which matches with the inverter nominal voltage. And with sensor inverters, we design with strings, I don't remember now exactly, about 20 panels per string in order to reach the standards. But I mean, it's a matter of location again and environment. And there in Sevilla, with a high temperature, the 20 panels per string was the best solution for the 320 poly. Then for every solution, we try to reach the best DC solution. Again, in order to reach the best performance ratio on field. I hope this answers the question. I don't know if I got completely right.
Well, obviously, to remind everyone who's listening, I mean, all questions will be passed over to the Jinko team and Roberto. So, if obviously you do need to go into more detail, I'm sure you'll be hearing from Jinko. And we thank you all for obviously submitting so many questions. I have a question here at the moment. Is there going to be any major difference in energy output of the plant if we use 340 watt poly or 340 mono or 340 HC mono?
Well, before to answer this question, I would like to remind, I made a small mistake. I mean, the biggest project is, again, yes, more than 1 gigawatt, but it's not in Saudi Arabia, but in Abu Dhabi. It's the Jinko's Wine project. It's more than 1 gigawatt, just to correct the first question you made.
Brilliant.
To come back to the second question, energy output. Then, it's, first of all, mono and poly are today pretty similar technology in terms of output, not in terms of material, but in terms of energy output is quite similar. There is no a winner, because again, if we are in Norway, if we are in South Africa, if we are, depending where we are, my best, let's say, advice is to run a simulation in order to understand what panel can get the best output in terms of energy. One thing for sure is that ALCEL and PERC technology can bring higher energy output. This is a clear message, because ALCEL is producing more, and it's clear because of the temperature coefficient is less, and then the output is more. Then with PERC as well, we are going to increase the efficiency. And I mean, the future of large-scale plant, I guess, will be the mix of these two technology, ALCEL plus Mono-PERC, in order to reach the higher power bin possible and the higher efficiency.
Okay, brilliant. Thank you very much for that, Roberto. I think we're going to go back onto the second question that we asked, actually, regarding the project, I believe, in Abu Dhabi. You explained the BOS for multi-megawatt projects. Do you want to say something about the BOS of the 1 megawatt of a 1 megawatt project?
The BOS regarding 1 megawatt project, so quite a small plant, you mean?
Yeah.
Yeah, well, of course, in this case, the price of the panel has a different impact. If you compare 1 megawatt to 50 megawatts, then in this case, we need to calculate with accuracy all the BOS costs, because maybe in such a small plant can be convenient not to go to the higher efficiency module, which costs more, but to stay in something in the middle, okay? Just to reach a good level of panel output, but still keep the BOS in a low level. But again, for sure, in this kind of plant, which is quite small. It's not really a large scale plant, but it's okay, still a big plant. The biogas has a different impact, a less impact to the final cost. I mean, the fact of changing the panel will have a different impact, but the biogas has a huge impact again.
Brilliant. Okay, sure. And to go on to more warmer climates, which panels are more suitable for tropical climate conditions?
For warm climate conditions, for sure, I mean, I think the best for now it's half cell poly and half cell mono. If we watch, let's say, and we take a thermal camera and we see working a standard poly close to the half cell poly or a standard mono close to the half cell mono, we can see immediately the difference can be between 2 and 5 degrees internal temperature, meaning, for instance, a 280 watt peak panel, the standard one at the same conditions, same temperatures, is producing 235, for instance, but the one with half cell technology is producing 240. I can imagine that, I mean, half cell is quite a new technology, but still, if by the testing on site, it's really performing better. That's why in work condition, I really suggest half cell technology.
Okay, sure. I'm going on to the half cells. I mean, are half cell panels compatible with 1500 VDC systems? And if yes, to what extent will it resist the PID?
PID? I mean, yeah. PID is a well-known effect, which actually belongs to the material. And we are really working hard in order to find the best bill of material to construct a panel with a really high PID resistance. So far, all our panels can withstand with all the standards. And I mean, also, the total standard condition from the INC will respect those. The only point of PID is that material matters. So that's why we are trying to deliver the best backsheet, the best frame, the best glass in order to avoid the PID effect. In the market, of course, the best panel can perform the PID-free is the glass module, which is actually really PID-free. But for standard models with frame, glass, and backsheet, we have PID resistance, and we try to do our better in order to avoid this phenomena, choosing the best material around the panel.
Brilliant, thank you, Roberto. I'm reading quite a few questions which are the same. It's quite hard to understand where they are asking the questions from, but can you get the tool now, and where can we get it, and where would it be available?
Okay, for now, this tool is only for internal use. Anybody can contact me and we can make calculations together. We can help them if they are interested. I mean, I'm not sure when will be available exactly, because it's not my decision, but it's my job, but it's HQ decision. Our management will decide if will be free for users, and we will put on site for in our website for the download. But I mean, it's just a really new tool. I worked on that the last 3 months. It's now already the first version, and still is not available for customers. I mean, we can work together. I can support doing pre-sale activity, all customers interested. But I mean, for now, it's not open to external parties. I will keep you updated if it will be yes or not. I'm not sure.
Yeah, it sounds very interesting, and I'm sure people are excited to have that available to them. Now, with regards to a question here is, why do you think half-cut cell modules are not often used for rooftop projects?
Well, the first point is it's a new technology. So I'm not saying that it's not bankable, but all the financial institutes look at it like, okay, it's new. We don't have a track record, so it's difficult to find immediately financial good situation for the investors. This is because it's new. It is quite normal. The second point is it's really a new product. So maybe some of the investors, actually many of them, they don't know about this technology. They don't have the feeling. They don't know about the output and the skills of this technology. And I mean, yes, those are the two major points of the fact that Alcel is not really still a famous panel, let's say, but it will be. I believe it will be because we are getting more and more customers asking and developing system with Alcel technology.
Sure, thank you. I totally understand. I think we probably have enough time for one or two more questions. We've got one here. What is the physical reason for better temp coefficient?
What is the physical reason to get a better temp coefficient?
Yes.
Okay, no. I mean, I think you can still see my screen, and we can go back some slides. I will show you the physical reason. Is this one? I mean, having the half of the current, we also get the half of the Joule effect. So meaning the temperature will be less because we will, in our panel, we will not reach 9 ampere, but only 4.5. And having less current, we will get less temperature. And if you think also to a hotspot problem, in our cell, with the hotspot effect, will have a less impact just because of the out cell output, which will be half of the current, meaning less temperature, less Joule effect, and better working condition and lifetime for the panel. That's, I mean, the major point.
Brilliant. Thank you very much. And more again with the coefficient. Do you consider the module derating coefficient in your tool?
Yes. Of course, I consider our line of derating. You can find the coefficient derating in all of our datasheet, and for every year in the 25 years, there is a derating coefficient in order to get the right lifetime energy output. So finally, yes, after the first year, where we have a certain, depending on the technology, derating coefficient, we will get the standard line coefficient derating. And yes, the answer is yes.
Brilliant. Well, I think that will conclude today's webinar. So I'd like to obviously once again thank you, Roberto, for joining us today. And obviously for more information, news, trends, innovations, please do read pbtech.org, sign up to our newsletter, and look for relevant conferences and exhibitions that we organize for the industry. So once again, thank you very much, Roberto, and thank you all for joining us today.
Thank you for the opportunity, Oliver. Thank you, PBTech.
Thank you.
Thank you also, everybody, for listening.
We all the presentation and recording of this webinar will be published on PBTech in the next couple of weeks. after editing, and we look forward to seeing you all again soon. And have a lovely afternoon, everybody. Thank you for joining.